At 8:20 a.m. on the 4th of May 2026, off the northern coast of Iran, the flight deck crews of the USS Abraham Lincoln are operating with surgical precision during a high-stakes exercise. The massive carrier turns into the wind, generating a 30-knot headwind, the ideal conditions for a heavy launch. A heavy silence of anticipation hangs over the ship as a precision strike operation is finalized. On the flight line, technical teams and ordnance handlers work with absolute focus, prepping strike fighters for an urgent sortie. Inside the ready room, pilots from the F-18 Super Hornet squadrons receive their final intelligence briefings. Their target lies deep within Iranian territory, the Fordow nuclear facility, a hardened complex buried deep inside a mountain of solid rock. Intelligence assessments confirm that the core sections of the facility are encased under massive layers of reinforced concrete and stone, making conventional airstrikes almost entirely ineffective. Near the catapults, ordnancemen are winching the final BLU-109 bunker busters onto 12 Super Hornets. Each aircraft's mission computer automatically runs diagnostics, confirming target coordinates and programming the bomb release sequences. Meanwhile, the strike lead reviews the mission plan one last time, ensuring every moving part is perfectly synchronized. Before we dive deeper, I want to hear from you. Drop a 9 inches the comments if you stand with the red, white, and blue. Type 1 if you're pulling for Iran, or if you're a peacemaker at heart, hit us with a 5. Now, let's get back to the cockpit. This operation demands tight coordination and timing down to the second. When the launch order crackles from the command center, the pilots scramble to their jets. One by one, the Super Hornets taxi to the catapults, their twin engines roaring as the first jet is flung into the sky. Every 30 seconds, another bird clears the deck, quickly joining the stack. Once the full strike package is assembled, the formation climbs to 20,000 feet and banks northeast toward the objective. As they breach Iranian airspace, the formation splits into tactical sections. Each group of 4 aircraft is assigned a specific aim point on the Fordow underground complex. The flight lead activates his targeting systems, monitoring a constant stream of tactical data shared across the entire flight via Link 16. During the planning phase, mission commanders weighed several options, including the use of F-35s, or Tomahawk cruise missiles. However, they concluded that this specific profile required a workhorse, a durable fighter capable of trucking the heaviest bunker busters in the Navy's inventory. The F-18 Super Hornet was the definitive choice. Unlike many other carrier-based aircraft, the Super Hornet is built for massive external loads, capable of carrying up to 17,750 pounds of ordnance, nearly 80% more than the legacy Hornet it replaced. This allows a single jet to carry multiple 2,000-pound bunker busters while still maintaining air-to-air self-defense, reducing the need for separate bomber and escort packages. The Super Hornet has a combat radius of about 449 nautical miles on internal fuel alone. This allows jets launching from forward positions or the USS Abraham Lincoln to hit deep strike targets in Iran while retaining tactical flexibility. When a mission requires more time on station, buddy-buddy refueling between aircraft in the formation can nearly double that radius. The pilots didn't know it yet, but this aerial refueling skill, often overlooked but vital, would be the deciding factor today. Choosing the Super Hornet for this op wasn't just about gear. It reflected unique tactical advantages for a hardened target like Fordow. While Tomahawk missiles can hit fixed targets from extreme distances, they lack the ability for real-time target adjustment. When facing a target that can change or is buried deep in a mountain, the inability to flex the aim point mid-flight is a major liability. The F-35 offers superior stealth for penetrating hostile airspace, but to carry the heavy-duty bunker busters needed for Fordow, the F-35 would have to sacrifice significant internal payload or range. The mission specifically required what the F-18 provides: high payload capacity, long loiter times, and a flexible targeting suite. These characteristics allow the strike package to hit the primary hardened targets and remain on station to re-attack critical nodes if needed. As the jets from the Abraham Lincoln close in on the target, the pilots receive the latest intel updates from the carrier. At 10,000 feet, the strike lead confirms the position of every bird 4 groups of 3, each assigned to specific tunnels within the Fordow system. Suddenly, the groups break off and go to MCON total radio silence to minimize their electronic signature. Everything goes according to plan until an unexpected flash pops up on the tactical data link. Recon sources in the area report that Iranian security forces have detected unusual activity and are deploying troops near the facility. Units are moving into defensive positions along the mountain ridges, roughly 4 miles east of the main target. The element of surprise is evaporating. The strike package has to neutralize these defenses before they can alert the entire complex. The lead flight drops to 6,000 feet, using terrain masking along the mountain ranges to stay below the radar. On their targeting displays, pilots see heat signatures clustering around the tunnel entrances activity inside the mountain. Recon units have already painted one of the main hangar doors with a laser designator. The beam is invisible to the naked eye, but the aircraft's sensors lock onto the spot with absolute precision. 4 Super Hornets synchronize their flight paths, approaching the release point simultaneously. Seconds apart, the first 2 jets roll inverted and pull into a 4-5-degree dive. At exactly 4,200 feet, the weapon system pickles the first blue, 109S. The bombs follow a ballistic arc, while the laser seekers make micro-adjustments during the 1-2 second fall. From the air, there is no immediate explosion. Instead, the bombs punch deep into the rock and concrete of the mountain before detonating internally. Seconds later, violent secondary explosions erupt from the heart of the mountain as fuel and supply depots are triggered. This internal devastation happens because the Super Hornet is carrying a weapon designed specifically to core through rock and concrete. The BLU-109 bunker buster is a fusion of massive weight and specialized engineering. Each 2,000-pound bomb carries a 535-pound high-explosive charge, enough to create massive overpressure inside an underground structure. The BLU-109's claim to fame is its penetration. It can punch through 8 feet of reinforced concrete or 20 feet of hard-packed earth before exploding. This is achieved through a thick, hardened steel casing and a specialized nose design that prevents the bomb from shattering upon hitting a hard surface. The programmable delay fuse is the secret sauce for underground strikes. It allows the bomb to penetrate deep into the structure before the boom, creating a lethal effect from the inside out where the thickest shielding becomes useless. By setting a 2.5 to 1.00 millisecond delay, the bomb clears the protective layers of the Fordow facility before detonation. When the blast occurs, the shockwave travels through the internal corridors instead of being absorbed by the exterior mountain. This pressure causes entire sections to collapse, paralyzing the facility's critical systems. But that was only phase 1. After the initial strike, 8 F-18 Super Hornets pull hard on the sticks and climb out of the target area. On the tactical frequency, the strike lead checks the status of every jet, focusing on fuel states. The aggressive combat maneuvers and high-speed runs have burned through 40% more fuel than planned. 4 jets are hitting bingo fuel, the minimum amount required to make it back to the USS Abraham Lincoln safely. If they don't refuel immediately, they'll be forced to abort early, which would compromise the next phase of the operation. Fuel warnings flash on the MFDs. The digits confirm the commander's fears. The flight needs gas, and they need it now. Just then, new contacts appear on the radar, 30 miles to the west. 4 more Super Hornets are inbound in a tanker configuration. Instead of bombs and missiles, they are carrying the aerial refueling system. The lead tanker signals, ready. One of the strike fighters' banks slows to 250 knots and approaches the tanker's 6. From the belly of the tanker jet, a refueling hose is trailed out, ending in a drogue basket. The fighter pilot gently nudges his jet forward, aiming the refueling probe into the swaying basket. The first attempt is a miss. On the second try, a solid clank echoes through the airframe as the probe locks in. High-pressure jet fuel begins pumping into the fighter's tanks. In just 60 seconds, it's topped off. This buddy store system, the A42R, One turns a standard Super Hornet into a flying gas station. With a transfer rate of 220 gallons per minute, an F-18 can be nearly refilled in about 75 seconds. In a combat zone, speed is life, as aircraft are sitting ducks while plugged in. A tanker-configured Super Hornet can transfer 8,000 pounds of fuel to its wingmen while still having enough to return to the Lincoln. This extra gas extends the flight's loiter time over the target by another 90 minutes, turning a smash-and-grab strike into a persistent pressure campaign. 30 minutes after refueling, 4 Super Hornets return to the Fordow area. They orbit at 18,000 feet, scanning the mountainsides with infrared sensors and radar, looking for movement around the tunnels. The BLU-109 strikes worked. The main entrances are collapsed, forcing survivors to find a way out through hidden emergency exits scattered along the ridge. These are the secondary bolt holes that intelligence experts had flagged. With the main doors blocked, anyone leaving the mountain has to surface at these points. On the lead F-18, the weapons systems officer suddenly detects a thermal anomaly on the central sensor display. The signal is coming from a narrow, rocky crevice on the eastern slope. The targeting system marks the spot and generates coordinates. On the IR screen, human figures appear clearly, moving fast and hugging the rocks for cover. The lead jet banks hard to give the sensors a better look. The WSO zooms in on the thermal feed from the ATFLR pod. As the magnification increases, 12 human heat signatures are visible. Several are carrying long objects, likely rifles. After analyzing the enhanced thermal imaging, they confirm these are hostile armed personnel attempting to flee the collapsed facility. The lead Super Hornet immediately fires its laser designator. The coordinates are shared across the data link to the entire flight. 2 jets peel off and drop to 12,000 feet for the attack run, maintaining a safe distance from the terrain. Each jet drops a precision-guided bomb, while the ATF LIR system guides the weapon all the way in. Seconds later, the bombs hit. On the IR screen, the frame flashes white for a fraction of a second from the thermal bloom before normalizing. When the image stabilizes, the aftermath is clear. Battle damage assessment confirms 12 targets neutralized. Without the high-tech sensors hanging under the right intake of every Super Hornet, these targets would have vanished into the jagged terrain and the shadows of the mountain. That sensor is the AN/ASQ-228 Advanced Targeting Forward-Looking Infrared, or ATFLR. It provides extreme precision for carrier-based strikers, like those from the USS Abraham Lincoln. Operating from over 40 nautical miles away, this system can track human-sized heat signatures, even when partially obscured by rock or structures. This standoff range keeps the jet safe from most shoulder-fired missiles while maintaining deadly accuracy. Even at max range, the system maintains a resolution of about 3.5 feet. This allows operators to distinguish an armed individual from an unarmed one, and even identify what kind of weapon they are holding. This resolution comes from an advanced mid-wave infrared sensor that detects microscopic temperature differences on a target's surface. With a laser designation error of less than 3 feet at combat ranges, precision weapons can hit specific doorways rather than just a general area. Unfortunately for those trying to escape Fordow, this was just the first wave in a long string of strikes being prepped in the skies above.